Circles and trigonometric functions. Objective: find a specific point on the terminal side of an angle. So we're going to look at this example where we find the point on the terminal side of the standard angle theta equals 2 pi over 3 that is 5 units from the origin, and we need to give the exact values. First, we want to locate what quadrant this angle 2 pi over 3 is in. So I look at the quadrant angles: 90 degrees or 1/2 pi, 180 degrees or 1 pi, 270 degrees or 3 pi over 2, that's 1.5 pi, and 360 degrees, which is 2 pi. 2/3 is more than 1/2 because 2/3 is 0.67 approximately. So it's more than 1/2, which would be 0.5, but it's also less than 1 pi. So 2/3 pi is in the second quadrant. So I'll draw an angle in the second quadrant and I'll label it 2/3 pi. And then I'm going to also label the radius or the distance from the origin to the point I'm looking for. That distance needs to be 5. So now I'm going to find the x and y values here by observing that I have a triangle. So let's zoom in a little bit and draw the triangle by dropping an altitude from here. And we get this triangle where one of the legs of the triangle is the x value and the other leg of the triangle is the y value, with the sign taken into consideration, of course. We know a leg of a triangle has to be positive, but obviously the x value here is going to be negative. Okay, so let's look at the definition of the sine and cosine function. So the sine of theta is the y value of the ordered pair over the radius, r. The cosine of theta is the x value over the ordered pair over the radius. So since I know the radius is 5 and I know that theta is 2 pi over 3, I just plug those in. So I get that the sine of 2 pi over 3 is y over 5 and the cosine of 2 pi over 3 is x over 5. And I'm going to solve both of these equations. I'm going to solve the sine equation for y and the cosine equation for x by multiplying both sides by 5. I'm going to go ahead and try to find what the sine and cosine of 2 pi over 3 are. Well, in order to do that, I'm going to look at the acute angle in here. So 2 pi over 3 is this obtuse angle. It's bigger than 90 degrees. So I'm going to focus on this little acute angle that would bridge the gap between the terminal side of the angle 2 pi over 3 and the straight angle pi. So this little piece right here is what I'm looking for, that arc right there. I'm trying to find out how much rotation that is. I'm going to take note of the fact that if I add that little green arc to the 2 pi over 3, I'll complete the entire straight angle pi, the 180 degree angle. So all I have to do to find this green angle is subtract 2 pi over 3, the given angle, from pi. So that's what I do. I do this angle here is equal to pi minus 2 pi over 3, which is pi over 3. Now pi over 3 is a 60 degree angle. So this is a 60 degree angle, meaning that the side adjacent to it, the x1, the x value, has to be half of the radius, because the cosine of a 60 degree angle is half. And the sine of that angle has to be the square root of 3 over 2, the sine of a 60 degree angle. And I'm just going to make sure that the x value is negative because I know the angle I'm looking at isn't acute. It's not a 60 degree angle, it's actually 120 degree angle. The sine of a 60 degree angle, like I said, is the square root of 3 over 2. I'm going to use that, just multiplying that by 5. But when I do the cosine, instead of 1/2, I'm going to use negative 1/2 because this point is in the second quadrant, so the x value has to be negative. And then I'm just going to do that multiplication. That's going to give me 5 square roots of 3 over 2 for y and negative 5 over 2 for x. So here I have the solution, the ordered pair that's 5 units away from the origin on the terminal side of the angle 2 pi over 3 is the ordered pair where x is negative 5 over 2 and y is 5 squared roots of 3 over 2. Let's look at a different example. Let's look at finding the point on the terminal side of the angle 7 pi over 6 that's 8 units from the origin. So first, let's identify where 7 pi over 6 is. So I'll identify the quadrant angles, half pi, 1 pi, 1.5 pi, and 2 pi. So 7 pi over 6 is more than 1, but less than 1.5. 7 pi over 6 is 1 1/6. So it's less than 1.5. That means that this angle is in the third quadrant, which means both the x value and the y value are going to be negative. So I draw 7 pi over 6 with its terminal side in the third quadrant. And then I'm also going to label the radius. So the radius is given as 8. I'm going to use a right triangle now in order to identify the sine and the cosine of this angle. And then I'm going to use the sine and the cosine to find the x and y value. So here's the triangle. So the sine of theta is going to be y over r. And the cosine of theta is going to be x over r. That means that the sine of 7 pi over 6 is equal to y over 8, the radius, and the cosine of 7 pi over 6 is equal to x over 8. Then I'm just going to solve for y and x respectively by multiplying both sides by 8. And now I'm going to figure out what the cosine and sine of 7 pi over 6 is by looking at this triangle and trying to figure out what this little acute angle here is. Now that acute angle is a little bit more than the straight angle pi. And if I take my given angle, 7 pi over 6, and I subtract pi from it, it should actually give me that little rotation, that little acute green angle there that I just put in. So that's what I'm going to do. I'm going to subtract the 7 pi over 6, which is bigger than pi, and I'm going to subtract pi from it. So 7 pi over 6 minus pi, which is just pi over 6, a 30-degree angle. So I have a 30-degree angle. So I can find the sine of a 30-degree angle and a cosine of a 30-degree angle. I just have to make sure that both x and y value I get are negative. The sine of a 30-degree angle is half. The cosine of a 30-degree angle is the square root of 3 over 2. I'm just making sure that both the x and y value I'm going to get are negative to justify the point being in the third quadrant. So I'm just going to do this multiplication. I get y is negative 4 and x is negative 4 square roots of 3. So the ordered pair that's 8 units away from the origin on the terminal side of the angle 7 pi over 6 is negative 4 square roots of 3, comma negative 4. Alright, last example here. We're going to find a point that's 1 unit away from the origin on the terminal side of the angle 7 pi over 4. So first, let's figure out where 7 pi over 4 is. Let's look at where the quadrant angles are. We got half pi, 1 pi, 1.5 pi, and 2 pi. 7 pi over 4, well, 7 over 4 is 1 3/4. 1 3/4 is more than 1.5, but less than 2. So this angle is in the fourth quadrant. And I'm going to draw an angle in the fourth quadrant and label it 7 pi over 4. And I'm going to label the radius or the distance from that point to the origin as 1. And now I'm going to draw my right triangle so I can figure out what the sine and cosine are to get the x and y value here. And the y value here we know is going to be negative. So let's look at the definitions. We know the sine of theta is y over r, the cosine of theta is x over r, and theta is 7 pi over 4 and r is 1. So that means that the sine of 7 pi over 4 is y over 1, and the cosine of 7 pi over 4 is x over 1. I'm going to look for this little angle here, which is the acute angle in my triangle. So to find that acute angle in my triangle, I would actually look at a full revolution, 2 pi radians, and just subtract away that green part from it. So I'm going to take 2 pi, which is a full revolution, and I'm going to subtract away the 7 pi over 4, which is the given angle. So I take a full revolution, subtract the given angle, I get pi over 4, which is a 45-degree angle. So that's a 45-degree angle, that green angle, which means that this is a isosceles triangle. X and Y are the same value. That means that I can use the sine of a 45-degree angle and the cosine of a 45-degree angle. I just have to make sure that the Y value is negative and the X value is positive because I'm in the fourth quadrant. The sine of a 45-degree angle is the square root of 2 over 2, and it should be negative because I'm in the fourth quadrant. And the cosine of a 45-degree angle is also the square root of 2 over 2, and that one should be positive. So my X and Y value then are just negative square root of 2 over 2 and the square root of 2 over 2. And that gives me the point on the terminal side of the angle 7 pi over 4 that is 1 unit away from the origin. This point would actually be on the unit circle because of the description.